So that brings us to I, which is the interface segregation principle. Now some classes have public interfaces that are not cohesive. They may include several groups of members where each group is used by a different set of client classes. The groups might be entirely separate, or there might be some overlap between the members used by different clients. Ideally, all classes should have cohesive interfaces, but of course this is not always possible. The interface segregation principle states that clients should not be forced to depend upon interfaces they don't use. When we have non-cohesive interfaces, the ISP guides us to create multiple smaller cohesive interfaces. The original class implements each interface. Clients can then refer to the class using the smaller interface without knowing that the other members in other interfaces exist. When you apply the ISP, classes and their dependencies communicate using tightly focused interfaces, minimizing dependencies on unused members and reducing coupling accordingly. Smaller interfaces are easy to implement, improve flexibility and the possibility of reuse. As fewer classes share interfaces, the number of changes that are required in response to an interface modification is lowered and therefore increases robustness. Okay, let's have an example. If you remember from the prior lecture, we had the issue whereby we had a product service that implemented two methods, an add and a get. However, there might be a situation where you would want a read-only product service that would only implement the get method. In this case, we had to override the base class's add method to throw an exception. Obviously, this isn't ideal. This is where individual smaller interfaces really come into play. So what we can do is we can write two separate interfaces, a readable interface and a writable interface. Each interface specifies the two different sets of methods. So for example, the read-only will be any get methods, the writable will be add, update, delete methods. We can then create our two individual product services and implement just the methods we want from the base interface. So for example, the read-only product service now just implements the readable product service. Whereas if we want a service that has full read and write capabilities, we implement both of the services. So as you can see, we can write two separate product services that implement just the interface we want to use. It also means if we want to make change to the writable service, it will not have any effect on the readable service.